Yes, sir, you are audible, sir.
Introduce yourself.
Sir, good morning to everyone. My name is Sudhir. Currently, I am pursuing MTech in National Institute of Technology, Soratkal in VLSI domain. I have completed my BTech in JNTU. Apart from this, I completed a certification course in Central Institute of Tool Design. I done a project on data multiplier using faster design technique in the Verilog code, using Verilog code, and a content.cellular automata using QCAD technology, and a home automation using FPGA board and Verilog.
Okay.
Me and my family are 2 members. This is all about me. Thank you for giving this out.
Okay. So suppose you have a Verilog code, you want to implement it on FPGA board. So how will you do that?
Firstly, we write a code and we use like instantiation, like FPGA board. We have to.
Which FPGA board you used?
SOC, sir. SOC. FPGA SOC board. I didn't remember that number, sir.
Okay. What is the full form of FPGA?
Field
The
program
difference between
gate array.
FPGA and ASIC.
ASIC is application specific integrated circuit, and FPGA is field program gate array. In ASIC design, we have to know we have a particular aim in it, and we didn't change the code as we want. In FPGA board, we can change the code and we can modify after the simulation also. If there is any error in the code also, we can change in FPGA board. Whereas in ASIC, we didn't do that kind of things. In ASIC, we have to get the certain aim of it, and ASIC is used for only a particular purpose. Like if temperature taken means temperature sensor means it is used for that purpose only. Whereas in FPGA, we can modify the code and we can use it to access anywhere. And ASIC is very costly, whereas FPGA is less than ASIC cost.
Okay. What is the advantage of FPGA over ASIC?
We can remodify the codes in FPGA, but in ASIC we can't do. If we do any mistake in ASIC, we have to rebuild the system again. It's a waste of money also.
Yeah. What is the frequency of FPGA board you have used?
I didn't remember, sir.
And can you tell me the memory of FPGA board? How much memory it consumes? Total capacity of FPGA?
I didn't get all this information of what the board used about it. We just implemented on it, sir.
Okay, suppose you have programmed FPGA board once, and you want to remodify and implement some other code in the FPGA board. So for that purpose, what will you do first in the FPGA board?
We have to change the Verilog code, sir. First, we have to change the Verilog code. Then, when we dump into the FPGA board, then it will contains program logic blocks in FPGA board and CLBs in FPGA, which would connect automatically by itself when we dump the code in FPGA board.
When you will dump the code in the FPGA board, then when it is already programmed, then it will show you that the board which you have connected is already programmed. How will you delete that program that is already implemented in the FPGA board?
How to delete a program in FPGA board, sir?
That is already programmed. Suppose you want to implement some new Verilog code, and previously some other Verilog code already implemented on it. You have to delete it and then implement your new code. So how will you delete that previous code?
I don't know about it, sir.
Okay, what do you mean by bitstream?
Sir,
Bitstream. Do you know what is bitstream?
bitstream is the package of values, zeros and ones.
Have you really implemented your code on FPGA or you have just read it?
Yeah, we implemented in FPGA boards. We do so many codes in FPGA board only by interconnecting. When we write the code, we plug into the CPU, CPU, and we dump the code by giving interconnections and by analyzing, by switching the inputs, and we get the outputs like that. We analyze.
There is a process, whole process of converting Verilog code and implement it on FPGA board. Explain step by step all the process.
First, we write the code, sir, and we didn't require any test bench for implementing in FPGA board.
Okay.
And by some options will be there, sir. We have to give a path to it like that. We have to give a path, and I didn't remember properly, sir. In another interview, I will perform about FPGA how I work of the things.
What you have to do is you have to implement some code on FPGA board and do it practically. Then you will have that knowledge that you can't have just by studying.
Okay, sir. Actually, I forgot it after long time. That's why we implement so many codes on it, sir.
Okay, what do you mean by programmable array logic?
Programmable logic. It is a programmable and fixed OR, sir.
Pardon?
It is a programmable and a fixed OR. The output of AND gates, all the AND gates, is connected to the fixed OR gate.
Okay. What is the advantage of programmable array logic?
Advantage.
So tell me, what do you mean by programmable logic array?
It is a fixed OR and it is the opposite of PAL, sir. It is a fixed OR and where program is connected with OR gates.
Which is better?
I think PAL, sir, but I think PAL, sir.
Why?
In this, it is like a SOP form. PAL is an SOP form where PLA in POS form. SOP form we can connect by simple gates. It takes very simple space also. Packaging is also very small than PLA.
Okay, it's studied properly.
Okay, sir.
Have you studied CMOS?
Yes, sir.
So tell me, why do you use PMOS in pull up and NMOS in pull down?
PMOS is it passes strong one, whereas NMOS will pass a strong 0. That's why we use pull up as PMOS and pull down as NMOS.
Can you explain it by equation?
Okay, sir.
How much charge, maximum charge it will charge?
Okay, sir. Okay, sir. Is it visible to you, sir?
uh, I'm not talking about that equation. Suppose you have uh, connect capacitor in output, that CMOS inverter, and then write the uh, charging equation of NMOS and discharging equation of PMOS.
Yes, sir. As a VGS is equal to VTH, as we take the equation,
Hmm.
where VG is connected to VDD.
Okay.
If we take NMOS as upside, in pull-up network, VG is connected to VDD and source is connected to Vout is equal to VTH. By taking that equation, Vout is equal to VDD minus VTH. We have to get a Vout is equal to VDD, but here we are getting Vout is equal to VDD minus VTH. That's why NMOS is not good for logic 1.
So what is the problem when it is coming with VD minus VTH?
Because it should satisfy VGS greater than VTH. It maintain that voltage VTH. Without maintaining that voltage, it never get on. If by taking
Okay.
in PMOS,
Okay. Suppose we have used NMOS in pull up and PMOS in pull down. So what behavior it will work?
sir. Okay,
What will be the
okay, sir. It's look like acts like buffer with it acts like buffer, but not give actual response of buffer. It will decay somewhat. If you give logic 1, it should be 0, but not it will be 0. And if you give logic 0 input as input, if it is not give as logic 1, but it will get somehow decay. But it is act as buffer.
So if it is acting as buffer, how can you say that?
No, sir. Sorry for it. If you give 0, then it will be 0 only, but it not as much as 0, but it will give somewhat. If you give 1 also, it not give as 1. Somewhat it will decrease. That I am saying. Sorry for it.
The proper answer of that question is that when you will use PMOS in place of when you will use NMOS in pull-up network, then it will not be able to charge the capacitor
Yes.
completely. And
Yes, sir.
when you use PMOS in place of NMOS, then it will not be able to discharge
Discharge
the
completely.
completely. So it will
Yes, sir.
charge only up to VT, and in case of NMOS, it will charge only up to VDD minus VT.
Yes,
In case
VTH.
of PMOS, it will discharge only up to VT. That's the main problem. Rail to rail voltage problem is the main issue here.
Yes, sir.
We are unable to achieve the strong zero and strong one when we use opposite that, and also along with that, delay of our circuit will increase.
Okay, sir.
So, what do you mean by noise margin?
Noise margin. Noise margin is defined as if you take in CMOS, logic 0, it should be around 0 to 0.8, whereas 1 should rise from 2.4 to 2.5. If you take like the 2.8 to 5 normally, the noise margin means the ability to get the output without any distortion. If the noise margin is huge, if the noise margin is huge, then there is a chance to get the proper output. If noise margin is very low, then the chance of if noise margin is low, then it's a chance to get correct output. If noise margin is high, then it is a chance of getting wrong output. Noise margin high is equal to VAH minus VOL. Noise margin high is equal to VOH minus. Can I draw the diagram, sir? These are the equations.
So, what is VOH and VIH and VIL and VOL?
Okay, sir. VOH is the. Can I draw another diagram?
Okay.
This is the diagram of it, sir. VIH is the input of high, voltage input of high. VIL is the input voltage input low. VIL is the output voltage low. VIH is the output voltage high.
Okay, tell me why we are unable to achieve exact 0 or exact 5 volt in our CMOS circuit.
But it is not in all the elements will not act as it will have some distortion and some all the things will be happen sir when we take the instrument. If we apply it is not as a real. If it is real, then here dV out by dV also -1 gain would be -1. But in a natural case, the gain should be infinite when we take as we take like output as high and output as low. We get some distortion. That's why I think that we didn't have V output as high as 5 like that.
Gain is infinite. How gain is infinite?
Gain is V out by V in, no sir.
Yeah. How is it infinite?
When we take impulse of it at a 0 volts, it should be give 5 volts, no sir. At the V in is equal to 0, output should be 5. It should be 5 constant for a V input to 0. At a sudden impulse at a 0, the input voltage V in, the change of input voltage is 0. It is constant there. It means 5 by 0, which is nothing but infinite gain. Well, we take in practical application.
If input voltage is 0, you are telling that if input is constant. So
if we give input V in is equal to 0, then output should be 5 volts, no sir.
So what is gain? Rate of change is gain or
rate of change of dV out by dV in, sir.
So if you are telling that V input is 0, then how can you judge that rate of change of V input is 0?
If we take a sudden impulse at 0 volts, then it will be like that only, sir.
Okay, what do you understand by operating point?
Operating point. It means VTP?
No. Operating voltage.
I don't have but operating points.
Okay, study it.
Okay, sir.
So now my next question is show me the graph of noise margin. Now suppose you have increased draw two more graph from minus where the slope is becoming minus VIL and VIH point. You make delay larger and delay slower. Draw the diagram and tell me that.
What, sir? I didn't understand.
Okay, my question is, do you know beta?
Beta.
Do you know the ratio that is beta NMOS divided by beta PMOS? R is the ratio that is called beta NMOS divided by beta PMOS. Beta NMOS is mu n squares W upon L of NMOS and mu n squares W upon L of PMOS.
Yes,
Suppose the value of generally the value of R is equal to 1 in ideal NMOS. In ideal CMOS.
R equal to 1.
Yeah, that is the ratio of beta NMOS divided by beta PMOS. Now suppose the beta of NMOS is greater than the beta of PMOS. So how will we affect the noise margin graph of the circuit?
If beta of NMOS greater than beta of PMOS, then I have to draw a noise margin graph, sir. In
both cases, if ratio is greater than 1, if ratio is less than 1, how it will affect the transition from -1 to -1, that is both NMOS and PMOS are in saturation. In that way, what will it affect?
Okay. Normally, the case is when a ratio when beta and the beta p is equal to 2.5, no sir. Normal case.
Pardon?
In normal case, beta n is equal to 2.5 of beta p, no sir.
Okay.
In mobility, due to mobility.
But in normal case, but I am talking about the ratio. If I am talking if beta NMOS is greater than beta PMOS, or if beta PMOS is greater than beta NMOS, then how will we affect the graph of mass time?
Okay, beta n greater than beta p and beta p greater than beta n.
And also keeping the aspect ratio constant of both the NMOS and PMOS.
As same, no sir.
And also keeping the aspect ratio of PMOS and NMOS same.
Okay, sir.
So listen, you studied properly. When you will come to the next time, you will study properly. What will happen in that case? That if
I think it moves left side, I think so, sir.
In which case?
In the beta p greater than beta n.
So it will move left side. Why?
Right now only I am analyzing, sir. I didn't get a proper answer, but it moves left side, I think so, sir.
So if the beta p is greater than beta m, it means that the mobility of PMOS is greater than mobility
Yes.
of NMOS. So
Yes,
in that scenario, PMOS will drive the circuit. So PMOS will charge the circuit faster, and in that scenario, the graph will shift towards the right hand side.
right hand
And
side.
yeah, and in the case when NMOS mobility is higher, then in that scenario, the graph will have sharp transition. The graph will move towards the left hand side.
Okay, sir. Why it is moving, sir?
Because
Please.
mobility is driving the driving strength of NMOS. That the driving strength of NMOS is greater than driving strength of PMOS. So if its driving strength is high, it will discharge faster. That's why it will move towards the left. If the driving strength of NMOS is low, it will discharge slow. So it will move towards right. Its transition will be slow. That's why.
Okay, sir.
Okay. Have you studied short channel effect?
Yes, sir.
What do you mean by short channel effect?
Short channel effect is nothing but when we increase the drain voltage. Can I draw and explain, sir?
Yeah. Right.
Sir, this is the diagram of primarily. Okay, sir.
Okay.
If we increase the drain voltage, generally this width is the overdrive voltage. Okay, sir. Startingly, VGS is equal to VDS only. It means here width and here width both are same in both direction. When we increase drain voltage, if suppose we take gate to water voltage as 3 volt, it means the width is 3 volt. Means if we increase the drain voltage as 1 volt, then the VDG, the width of the VDG is changes to 2 volts, but VGS it should be 3 volts only. When we increase the drain,
you are talking about the pinch off point when we are, that's not the case in short channel effect.
In short channel effect, by reducing the channel length, it will increase the E is equal to V by D. By decreasing the length, it increase the voltage, it increase the electric field, then it moves, it increase the electrons velocity.
Okay, how will it increase the electron velocity?
When we analyze the equation C is equal to V by D,
Okay.
as the distance is decreases, as the length is decreases, the electric field will be increases, as well as voltage will be increased. Electric field, it makes the electrons move faster.
Okay. Does charge sharing happens in short channel effect?
Charge sharing. I think it is not possible. I think so, sir, because charge sharing means the voltage should be same, but here it is above the saturation voltage. It is overdrive the saturation voltage. When we see the graph,
No. Charge sharing is one of the features of short channel effect.
but the graph will close like this, no, sir.
What happens in short channel effect when we reduce? Suppose we are working in 180 nanometer, we have reduced the channel to 7 nanometer or 14 nanometer. So many of the factors which are affecting the CMOS changes. Now the current is not totally dependent upon VGS. It also now depends upon VDS. It becomes a function of VDS when we reduce the length to a much extent. And also when we reduce the length and the depletion region length is very much decreased. So in that scenario, when the depletion region length is very much reduced, and when we increase the VDS, so a strong electric field occurs between the drain and the source. And also when we increase as CMOS works in the reverse bias condition, when we increase and also the short channel effect, the depletion width become comparable with the channel length. So when we increasing the VDS, the channel length, the length of the depletion region also increase. And when we increase VDS more than saturation, more than VDD, then the situations comes that the depletion region of both the source and drains matches with each other, and VT is dropped to a very maximum extent. VT is dropped very much. So even a small gate voltage can drive the electron from source to drain.
Yes.
That's what happens in short channel. So study it properly. You are explaining some other things.
Okay, sir.
So you have studied very long?
Yes, sir.
So what do you mean by synthesizable and non-synthesizable?
Synthesizable means which we get in form of gate, where non-synthesizable means we didn't transform into gate format, like X or Z, which is non-synthesizable, where synthesizable are 0, 1, like that value, synthesizable values.
So is always block is synthesizable?
Yes, sir. Always box is synthesizable, where initial box is not synthesizable.
And do you know inertial delay?
Yes, sir.
What do you mean by inertial delay?
Inertial delay is the delay which is to get the output, the delay which is occurred due to the change of input and the propagation delay of the gate. It takes to the output is known as the initial delay. The initial delay will have as a reject pulse, like it doesn't transfer what the waveform look like. In inertial delay we have reject pulse also. Like if you write a reject after 4 nanoseconds, the width which is less than 4 nanoseconds, it should be eliminated. The width which is greater than 4 nanoseconds, that will be transformed in inertial delay. Whereas in transport delay, it will transform all the waveform as it is with taking of delay.
Okay, can you give me the example of initial delay and
Okay, sir.
transport delay?
Is it visible, sir?
Yes, visible. Explain it.
We got it, sir. Then, if you take clock delay, a clock as a zero, and after 5 nanoseconds as a drop from rise to fall, then if you take the input as zero like this, if you take input like this, if it is a clock, first one is the clock, second one is the input, and the third one, if you see in between of 1518 input, there is a 3 nanoseconds delay only, but we given in initial delay 4 nanoseconds. It means it should reject the pulse. The input which is the input at 15 nanoseconds, that will only continue up to 20 nanoseconds. Whereas in transport delay, uh, it will propagate the delay same as the waveform of the input, but it gives 4 nanoseconds inertia, 4 nanoseconds input delay.
Okay. Also, you can take another example of when we use hash symbol for any time delay in Verilog. That is also a type of transport delay. And the delay provided by the always block at the rate when the transition occurring in any of the input, then the delay at which the transition is occurring. Am I audible?
Yes, sir. Yes, sir.
The delay at which the transition is occurring in the input when we use at the rate in always block, that type of transition is called uh, uh, inertial delay. And another delay when we use external delay, when we are using any delay in between the two statements, uh, that type of statement when we use
Transport.
transport delay.
Means
So
A is equal to 5, as 20, B is equal to 10 means as 20 is the transport delay.
yeah,
Inertial delay, sir, A is always at the rate.
yeah, the delay that is occurring when the input, when the suppose there is a transition of input occurring, but that transition is more than the clock period or much larger than the clock period, then that will not count
Yes,
when
sir.
we are using always block. So in that scenario, we can understand the transport, and it's actually the wire delay, we can say.
Okay,
So
sir.
is it synthesizable or not?
Which one, sir?
Transport delay?
Transport delay. I think timing delays are not synthesizable. I think so, sir.
Okay. Do you know design compiler?
Design compiler. Yes, sir. There are. Mm, yes, sir. Design compiler means two compilers will be there, no, sir. Interpreted compiler and that was the only, no, sir.
Design compiler is mainly used to convert RTL code into gate level netlist. That is the purpose of design compiler, and it does some DRC check that and do some optimization in the circuit, and that can be implemented in hardware. Verilog code we can only implement in FPGA board, but we cannot use it into hardware unless we synthesize it. So now tell me, what do you mean by RTL?
RTL is the registered transistor logic. Uh, it means it contains of gates. It means will code transformed into gate level netlist. If the transistor level netlist is known as RTL, where RTL contains of all the gates, AND gate, OR gate, NAND gate, like that.
No, that is the gate level. RTL is different from gate level. You can understand in a way that it just defines the behavior of the digital system. We 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 are using many circuits in RTL code like register, combinational logic, and register to register transfer. Basically, it is a combination of behavioral and structural modeling. So, in which we can analyze all the digital circuits. But gate level netlist is not present in RTL code. Gate level netlist is only done after synthesis using design compiler.
Okay, sir.
So, what do you mean by procedural block?
Procedural blocks, it contains two blocks are always block and initial block. Uh, in always block, always block will be execute when the parameters will change, whereas in initial block will execute only one time. In always block, it will execute it is a loop type.
Where do we use initial block?
We use initial block in when we initialize the values in test bench, like that we will use.
Okay, have you studied static timing analysis?
What, sir?
Static timing analysis.
Yes, sir. Yes, sir.
So tell me, what is the purpose of Slack in static timing analysis?
Slack.
What do you mean by Slack? And explain what is the use of it.
Slack is defined as the difference between the required arrival time minus arrival time. If required arrival time minus arrival time greater than 0, then there is no effect in the output. Whereas required arrival time less than arrival time, then the output may changes. If required arrival time greater than arrival time, then we think that our circuit is in good condition, right? Good condition.
Okay, what is the advantage of positive slack?
It will never give any wrong. We expected that it will come after 10 nanosecond, but we get the output as 5 nanoseconds only. We didn't bother about it. Then there is no violation in it. If it is a negative slack, then there is a violation will be arise.
That's not the correct way to explain. You can understand it in the way that when we have positive slack, then we have the time window. Suppose in a circuit, if there are some setup time and hold time violation are occurring in any of the modules of the circuit, then if we can use that time to remove that setup time and hold time violation, we have more window. That is, we have some positive slack. So that window we can use to eradicate setup time and hold time violation. That is advantage of slack.
By using positive slack, we remove setup and hold time. That like I have to say, no, sir.
Yeah.
Okay.
So have you studied crosstalk?
Crosstalk, yes, sir.
Explain.
Crosstalk means nowadays we are designing the circuit by reducing the length. When we reduce the length, then when we reduce the size of the chip, then there is a chance of two wires maybe connect each other. Then the value of 0 may changes to 1 and 1 may changes to 0. That will be taken in crosstalk.
No, it's not necessary that they are touching each other.
Yeah, when there is a near to each other also, there is a chance of discharging capacitor like that. If can I draw a diagram, sir?
You need not to.
Okay, sir. If a line it contains one value, it contains one capacitor, and a line 0 another one. The capacitor discharge like that, it will change, sir.
Yeah. It happens like that when we are doing design rule check. Suppose we have a circuit, we have synthesizers, then we do some design rule check that the circuit is meeting our requirement or not. So when we are doing design rule check, then in design rule check there is some criteria that the two wires should not be closer than this length, and also the midpoint and the midpoint of the both wires should not be less than this length, and also there are many 1000 types of rules protocols that should be followed by the any design. So in that scenario, when the distance between the two wires becomes less than that defined wire by design rule check, then crosstalk condition occurs. What happens in crosstalk is that when we reduce the length to a certain limit, then there is chances that the capacitance is found between both the wire and the or suppose one wire is at logic high and one wire
Yes, sir.
is at logic low. So the logic can transfer from one wire to another wire, and both the wire get disturbed. It can affect the noise margin. Also, interference can occur in that crosstalk. So
Yes,
that is the. Have you studied jitter?
yes, sir. Uh, Clock jitter means, can I draw a diagram and show it, sir?
Okay, sorry.
Suppose it is the normal clock, sir. It is visible to you, sir.
Yes, sir.
It is
Yeah.
a normal clock. It starts from zero, but it starts from zero. It's a time period of 10 nanoseconds. It starts from zero. Like that, it is going on. The next clock pulse, it will not starts at again at zero only. Like that, it will start around +1 or -1. Like that, it will be, has some uncertainty. That is not clock jitter.
So how will it arises? How does it happen? So we want to give clock at 0 time second. It is coming at one picosecond. The clock starts at 1 picosecond. So how does that behavior? How does it happen?
Due to the wire delay, it will due to the wire delay, like that, it will may occur, sir. Wire delay like that. That's why we use the tree to reduce the jitter. We use the trees like a H tree, X tree, I tree, like that, to get all the things like that same, like that.
Yeah. Uh, the you are talking about H tree, X tree. That is used to reduce the
Skew.
skew,
Yes, sir.
skew in the
Skew. Yes,
not
sir.
that jitter. Jitter
Yes.
generally arises when first tell me how do we generate a clock?
How we generate a clock? The clock should be generated by T flip flop.
No, no, I'm talking about the device. What do we use to generate a clock in real chip?
To generate a clock in real chip.
In real
Uh,
circuit,
okay. It means a stable multiple, like that, sir.
we have to generate a clock. We have need some source to generate a clock. So how do we generate a clock? I'm asking.
Generate a clock.
Okay.
I know the code to generate a clock,
No,
but
no, I'm not talking about the code. It's generated by the two process. One is oscilloscope and another is crystallographic technique. So these two techniques are used to generate a clock. So
oscilloscope and
crystallograph.
crystallograph. Thanks.
So when we generate the clock by using that two clock generator, what happens is that it is sensitive to the temperature. When the temperature becomes high or becomes down, so there is some variation in the clock due to that temperature and process variation. So in that scenario, there is chances that the clock is generated after some delay. That's what the reason of the
Okay, sir.
jitter. And what are the problems when jitter is created in the circuit?
Then the stability will not takes place, like a setup time violation, hold time violation, it will takes place, and the value at 0 it comes as 1. The whole circuit will be damaged.
No, no, it's not like that. Jitter time is too low that it won't violate the setup time and hold time violation. If the problem in jitter is that due to jitter, interference and noise is injected in the circuit, which can change the functionality of the circuit.
noise Noise interference will take place and it changes its function, means it changes to 0 to 1, like that, or else.
Yeah, yeah. When the noise is injected in the circuit, what happens is that it can come into the noise margin range. We have low noise margin and high noise margin. So the input can come in between the low noise margin and highest noise margin, and it can come in the highest noise margin in an undefined state. Its logic matching. That was
Okay.
the problem is caused due to jitter.
Okay, sir.
Okay, that's enough for that today. you need to work a little bit more. Then everything is fine, but you need to study in more depth. You have knowledge of everything, but when it comes to the depth, you little bit lag in that. So you need to study in depth, not every topic, but the topic that is important. The question I have asked, it's generally asked in interview. So
Okay, sir. I will revise all the things.
Okay. Have a nice day.
Thank you, sir, for it.